So first of all, where do they come from? And they only count for measured numbers, because this is why you've never seen them before in science, because generally chemistry is the first class where you're really talking about measured values. So for example, if we're going to find the mass of an apple, we would throw it on a balance, and this measurement is 99 grams. So the significant figures come from the measurement instrument. And some balances would be a little bit more precise, maybe measured to the 10th or the 100th, and that would give us more significant figures, or sig figs. So what about analog systems? That would be old school, like measuring the length of this Post-it note. So when we do scales like this, we're going to record all known digits. So I can tell this is a 5. I can see that it's right on the 0.1, and then I'm going to estimate one more place. It's right on the line, so I will call that 5.10 centimeters. That would be the width of the note. So those are all significant figures. They came from that measurement instrument. Now I could use a ruler that is less precise or more precise, and that would give me the number of significant figures. So in chemistry, we use a lot of measured numbers, and that's why sig figs are a big deal. In math, you're dealing with exact numbers, like 2 is 2. It doesn't have significant figures. So let's go over the rules so that you can look at a number and determine how many sig figs it has. First of all, the first rule is non-zero digits are significant. Now, I like to underline significant figures, or sig figs. So the 1, the 2, the 4, and the 5, those are all significant. So this one has 4 sig figs. And I further abbreviate SF. So like if I'm grading papers, -1 SF for sig figs. My students hate that, I know. But once you get this thing right, you will be good for the rest of the year. So hang in there. All right, the next rule is the sandwich rule. That's what I call it. If we have zeros that are sandwiched between significant figures, so the 1 is significant, the 5, those zeros are sandwiched. So those are also significant. So we've got 4 right there. The next number, the 1, the 5, and then a sandwich 0. So we have 3 sig figs. And then look at the last number. It's in scientific notation. This is really cool. All the sig figs are up in the front end, or the coefficient of that number. So all you have to do is count the digits in the coefficient, and that's how many sig figs: 1, 2, 0, and 9. And then what is this on the back end there, that exponent? That's just a bunch of zeros after those significant figures. All right, so what about zeros that are not sandwiched, but that are on the ends? Well, it depends on what that 0 is doing. So if it is only holding place value, it is not significant. For example, I have a 1,000 milliliter. There is only 1 sig fig in that number. What are those zeros doing? They're just holding place value, so that's not significant. The next number, I have a bunch of zeros, and then I have 2 sig figs. What are those zeros doing? They're placeholders, not significant. And then again, my number in scientific notation. And then let me show you this. Did you notice that those two numbers are the same? So where do all those place-holding zeros end up? They end up in the exponent, right? So the only important numbers are the 1 and the 2. So those are a couple examples of sig figs. Now, ending zeros that are significant, there are reasons to put them there, such as when I measured that Post-it note at the beginning of the video. So look at this number. The 1, the 5, and the 5, of course, are significant. Now, what about that 0 after the decimal? Is it a placeholder? No, somebody put it there for a reason, and that is to show precision. So they measured in a graduated cylinder 155 exactly, so they estimate one more place, 0.0 milliliters. So there are 4 sig figs there. This one could have been a balance that reads to the nearest thousandth, so there are 3 sig figs there. Those zeros are not placeholders. Someone put them there to show precision. That is more precise than, say, zero point 0.1 grams. That would be 1 sig fig, and this is showing 3 sig figs of precision. And then the last number, scientific notation. Remember, if a digit is in the coefficient of the number, it is significant. So the 1, 2, 0, and 0 are significant, 4 sig figs in that number. It just takes a little practice to get these sig fig rules down. So I hope this helps. You can do sig figs in chemistry.